So in this video, we're going to talk about standard deviation. So we're going to use our same data set, okay? And this time to find a standard deviation, this is measures how spread out the numbers are in a data set. This is super handy, and when they talk about, I don't know if you'll ever hear your parents talk about it, but they talk about the bell curve. We're going to talk about that later on in a couple of days, but this is how they get the numbers in the bell curve, and professors in college will sometimes grade on the curve, and this is what they're talking about, but we have to understand how to make that calculation. So that's what we're going to do in this problem here. The steps to doing this, and I wrote out the steps just so you can refer back to them if you need to. You need to find the mean, then you find the difference of the mean in each number in the data set, then we square the difference, you find the mean of the squared differences, and then we take the square root. It seems like a lot, and if you ever look at the formula for this, it looks kind of like a nightmare. So I never do the formula, I just set up this chart, and I know my chart is kind of funky because it spreads over a couple of slides here. So we luckily already calculated the mean way up here in the first problem. So we know that our mean, unfortunately, has some ugly decimal places, but we know our mean is this. So I'm going to use that as my mean, a 72.455. So I'm going to write that in this part of my chart, 72.455. And when you're doing your mean calculation for your homework, you can just set up this chart and use that, okay? So now I need to find the difference between this number and all of these numbers. So basically what I'm doing here is I'm subtracting 72.455 from all of these numbers. So when I do that with 6, I get 8.455. And with 48, 24.455. And this is going to be ugly because I'm doing 11 numbers, but I'm doing an exact sample of what you're going to have to do for homework tonight. So negative 2.545, negative 17.545, negative 8.545, negative 10.545, negative 1.545, negative 2.545, 10.455, and 14.455 and negative 8.545. It really doesn't matter if you're positive or negative, because look at what we're going to do. We're now going to square these numbers, and all of those numbers squared, remember, a number times itself is just going to negative times a negative would end up being positive. So the numbers here, and it's going to look crazy because I want to write down more decimal places. So the reason I'm writing down more decimal places is because, especially when we tend to go towards something like calculus or AP stats, is that we need our numbers to be accurate to a certain number of decimal places. And if we truncate that or round it in the middle, we won't get that accuracy. So we're going to pretend like we're actually the calculator and we keep more decimal places in the middle. So all I'm doing is squaring each one of these numbers. So 6.70725, you'll see a lot of 2.5s at the end. This one was 307.827025. And then I'm doing 73.0170025. And you guys, you should, as you're doing this, go ahead and actually do the calculation. So it's actually take and square that number. And again, you can use a calculator to do it. So 111.197025. And then 2.387025. And then 66.477025. And 109.307025. And then 208.947025. And then 73.0170025. So now that I've got all of my squares, I'm going to add those up. So when we're going to do a mean. So I'm going to add them up. When I add them up, I get 1568.180725. And then I'm going to divide that by 11. That's going to give me the mean of my squares. So the mean of my squares is 142.5618. Now, this has actually a special name. It's called the variance. Sometimes it comes up and sometimes it doesn't. It's not going to come up in our work, but if you ever need the variance, that's where it's at. Then I'm going to take the square root of it, and I'm going to use, I forgot to show you the symbol for me. There is a symbol for standard deviation. It's actually a baby sigma, so that's actually the symbol for standard deviation. I take the square root of this number, this 142.5618, and I end up with 11.93, and I got 99 on my calculator, so 11.940 would be the standard deviation. The other thing I forgot to show you was the symbol for mean, so you might see that it is x bar, and that just is the symbol for mean. The other thing is we're actually doing the standard deviation for the standard deviation population. There's a slightly different calculation. They're very, very close, but when we're actually look at this later in the week, we're going to need the population standard deviation.